As data analysts, we do ask ourselves a lot of questions. Let's tackle 5 of them today. First one being, what does the crisp DM methodology for data mining entail? And what does data analyst do in each step? Well, data mining, as a reminder, is not about just getting and sourcing data. It's mostly about the whole process to the first insights. So the first steps in crisp methodology of data mining is business understanding, in which we have to first assess situation, meaning determining resources availability, project requirements, assess risks and contingencies, and conduct a cost-benefit analysis. We do have to determine data mining goals. In addition to defining the business objectives, we should also define what success looks like from a technical data mining perspective. And produce project plan, select technologies and tools, and define detailed plans for each project phase. Second step is data understanding. We first have to collect initial data, acquire the necessary data, and if necessary, load it into our analysis tools, describe data, examine the data and document its surface properties, like data format, number of records, or field identities, explore data, digging deeper into the data by queries, visualizations, identifying relationships among the data, and verifying data quality, how clean and dirty is the data, and documenting any quality issues. A third step is data preparation or data munging. By first selecting data, we have to determine which data sets will be used and document reasons for inclusion or even exclusions. Cleaning data, often this is a lengthiest task. Without it, we likely fall victim to garbage in, garbage out. A common practice during this task is to correct, input, or remove erroneous values. Construct data, derive new attributes that will be helpful. For example, derive someone's body mass index for height or weight fields. Then integrate data by creating new data sets by combining data from multiple sources. And even format data by reformatting data as necessary. For example, we might convert string values that store numbers to numeric values so that we can perform mathematical operations. The fourth step to the crisp DM methodology is modeling. We should select the modeling techniques, so determining which algorithms to try, regression, neutral net, etc. Generate test design. Pending your modeling approach, we might need to split the data into training, test, and validation sets. Then we build the model. It sounds glamorous, but it might be executing just a few lines of code. And then assess the model. Generally, multiple models are competing against each other, and we as data analysts or scientists, we need to interpret the model results based on domain knowledge, the predefined success criteria, and the test design. The fifth step is evaluation. By evaluating results, by answering, do the models meet the business success criteria? Which one should we approve for the business? Review the process, reviewing the work accomplished. Was anything overlooked? Were all steps properly executed? We should then summarize findings and correct anything if needed. Determine next steps based on the previous 3 tasks. Determine whether to proceed to deployment, iterate further, or initiate new projects. And then final step is deployment. Plan deployment, developing and documenting a plan for deploying the model. Then planning, monitoring, and maintenance by developing a thorough monitoring and maintenance plan to avoid issues during the operation phase. of the model, produce a final report. The project team documents a summary of the project, which might include a final presentation of data mining results. And then finally, a review of the project. Conduct a project retrospective about what went well, what could have been better, and how to improve in the future. Second question for today. Explain what needs to be done before we can forecast time series. In other words, what does time series analysis involve? Well, time series forecasting is a technique for the prediction of events through a sequence of time. It predicts future events by analyzing the trends of the past on the assumption that future trends will hold similar to historical trends. We'll then need to assess many things. The volume of data available, the more data is often more helpful. The required time horizon of predictions, shorter time horizons are often easier to predict with higher confidence than longer ones. Forecast update frequency. Forecasts might need to be updated frequently over time or might need to be made once and remain static. And type of series, mainly if stationary or not. And according to the result, a transformation into stationary data series will help with the accuracy of the model's prediction. A third question, as we go along using data, are what are the main principles of data ethics, as well as what companies or organizations could do to uphold these principles. We'll go for about 6 main principles I found on data ethics. First one is ownership. Each individual has ownership over their personal information. It's unlawful and unethical to collect someone's personal data without their consent. Obtaining consent is mainly through signed written agreements, digital privacy policies that ask users to agree to a company's terms and conditions, or even pop-ups with checkbox that permit websites to track users' online behavior with cookies. Second principle to tackle is transparency. Data subjects have a right to know how we plan as data analysts to collect, store, and use their data. Then we have principle of privacy. Any personally identifiable information, known as PII, have to be kept private, meaning full name, birth date, address, phone number, social security card, credit card information, bank account number, any ID number, etc. To protect individuals' privacy, we then have to secure the database through encryption, decryption methods, password protected access, etc., so it doesn't end up in the wrong hands. Another way to prevent slip-ups is by de-identifying a dataset, leaving only anonymous data. The fourth principle is data minimization. By only using the personal data necessary to achieve the objectives of our research. The fifth one is accuracy. The personal data must be accurate. And the last principle is storage limitation. Personal identifiable information shouldn't be kept longer than necessary for our current research or even for possible further analysis of the data. As a reminder, in Europe, the General Data Protection Regulation, known as GDPR, is the founding data protection text and asks companies to be accountable, meaning they should be able to demonstrate compliance with the principles above. Another question for today would be about bias in data. So let's imagine we are an analyst at a financial services company, and we have some concerns about bias in the way a predictive model was measured. How would we raise our concerns with the manager? So as a general rule, I would ask for specific questions about the data collecting methods, its sources, its previous uses, and the end result of the study. If this discussion with the manager doesn't evolve towards potential bias naturally, I would openly tell him about my own concerns. For example, if the study is about future risks attached to loans, and the predictive model is only based on data from another country, or has an old range of dates, or is mostly about clients not repaying their credits, the model will most likely not be accurate enough. So then I would suggest to make sure the data used is as complete and relevant as possible, even if it involves starting all over again or maybe pointing out some limitations of the raw data available in the company. Last question for today is about the difference between regression and classification models in predictive analysis. When would we use one of these models over the other? Well, there are two types of predictive analytics: classification models and regression models. Both are part of supervised machine learning, but classification models only discrete variables, while regression models continuous variables. So the first one, classification models, what are they used for? They are used for binary predictions, either it's yes or no, true, false, hot, cold, etc., and could answer, for example, if this customer will buy this product again or not, or even for non-binary predictions, and could answer, for example, what product will this customer buy next. Predictive analytics by classification always gives us a category or class as a result. Then the regression models are used to predict the performance of something by predicting what will happen from an infinite number of possibilities. For example, the number of products that a given customer will buy in a given month. Predictive analytics by regression always give a number as a result.